All right, good morning, everybody. Let's do this. So, how are we going to solve absolute value equations? So, a long time ago, you remembered, oh, Mr. G, if I had the absolute value of, I don't know, let's say 6, for example, that's equal to 6. Or if I have absolute value of -6, that's still equal to 6. You say, Mr. G, whatever's inside here, you just make it positive. That's what it means for absolute value, anytime you see this symbol. But the question you have to ask is why? And this is the definition. How far a value is from 0 on the number line defines what it means to be absolute value. So, for example, let's say we have the number 4. And I say I want to find the absolute value of 4. Well, you say, Mr. G, it just becomes positive, right? Well, yes, it is 4. But the reason is because if I have 4 and I want to take the absolute value of 4, what does that mean? You're taking how far a value is from 0 on the number line. You're taking distance. I should have probably wrote that down, but you're taking distance, okay? So let's say if 4 is here, what is the distance from 4 to 0? It's 4. It's just 1, 2, 3, 4. If I say absolute value of -3, you're calculating the distance from -3 to 0. What is the distance from -3 to 0? It's just 1, 2, 3. Right? So that's why, and remember, distance is always greater than 0. Right? So this is why our absolute value can never be negative, because distance can't be negative. Okay? If I say absolute value of 0, that's just equal to 0, right? Because if you're here, what is your distance from 0? There is no distance, okay? So here, we got to go through some examples of how to solve some equations. So here, let's look at the first one. Question: if I say, what is the value of x, right? What can I put in here to make this equation true? Well, let's see. I could say x is equal to 10, right? Because if x is 10, then absolute value of 10 equals 10. 10 equals 10, and then it's true. But I could also use x equals -10. So because absolute value of -10 is 10, is this question mark true? And yes, that's true. 10 equals 10. Okay? But what if I wanted to say find x where the absolute value of x is equal to some number, right? And this is where we have a theorem. And it basically says that if you have absolute value of x is equal to a, where x is a variable, and this a has to be greater than or equal to 0, then x is equal to a, or x is equal to -a, okay? So when you first read this, you're like, Mr. G, what on earth are you talking about? I don't understand. You went too fast. Well, let's do some problems, and we'll see if this theorem can make sense for us, all right? So here, I want you to write it down, and we're going to go back to this theorem every single time, right? So let's look at the first question we have. Okie dokie. If we have this question here, and what I'm going to do is I'm just going to fold this so we can come back to it. All right, this is going to be our important theorem. And I'll just put it over here on the top, and let this look nice and organized. Okie dokie. So, there we go. Alright, so first question. It says absolute value x equals 6. So here, let's use our theorem, right? It says if the absolute value of x is equal to a, here the absolute value of x is equal to 6. So here, is our a value, is this value greater than 0 or equal to 0? Yes. So we could use this move. This is the move. You say x is equal to 6, because you take the positive version, or x is equal to -6. Okay? That's it. Let's look at the next one. You have x plus 3 is equal to 5. Here, when they're saying absolute value x equals a, it just means something inside here. Something inside here is equal to 5. So we could do the formula. What it does is it breaks. You say x plus 3 equals 5, or x plus 3 is equal to -5. Okay? you have to take both into consideration. If I say x plus 3 is equal to 5, what does x equal? You just do minus 2, x equals 2. Or if I have here x plus 3 equals negative 5, I can say, what is this, minus 3, x is equal to negative 8. X has two values. Well, let's just check it real quick. Check. If I were to plug this 2 into here, what do I get? I get absolute value x plus 3 equals 5. Absolute value of 2 plus 3. Does this equal 5? Absolute value 5 equals 5. 5 equals 5. Check. Right? What about here? X equals negative 8. This is x equals negative 8. This is x equals 2. So if I have the original x plus 3 equals 5, now I substitute this negative 8 in here. So negative 8 plus 3, absolute value equals 5. Negative 8 plus 3 is negative 5. Does the absolute value of negative 5 equals 5? 5 equals 5. Check. Okay? So that's what you're doing. When you're solving these equations, you want to get this absolute value by itself so you can break it into two. Okay? What I want you to do is try and do this problem as well. It's very similar to example 2. Absolute value of 2y minus 4 is equal to 7. What's your first move? Follow the theorem. You're going to break into two parts. Right? You're going to say 2y minus 4 equals 7, or 2y minus 4 equals negative 7. Okay? And then you solve for y. Okay? Then what does y equal? So here, what do we do? Plus 4, so 2y equals 11. And now you divide by 2, y is equal to 11 over 2. Okay? Don't be afraid to get fractions. Here, I do plus 4, so now 2y is equal to negative 3. Divide by 2, y equals negative 3 over 2. Okay? Don't be afraid of fractions. Getting fractions is okay. But you're like, Mr. G, we don't believe you. Well, what can we do? We could always just check our answer. What I want you to do is check y equals 11 over 2. Does it work? Check if y equals negative 3 over 2. Does it work when you plug it into the original? Okie dokie. Oh man, this is very sloppy. Alright. What I'm going to do is I'm going to pause the video just to save time, and I'm going to check it real quick. Let's see what happens. I know some of you guys still get a little lost with this, but let's say we're checking y equals 11 over 2. Let's see if it works. So this is the original equation. You plug this y into where it is. You plug this y into where it is. And then you say, Mr. G, I get lost here. How do I multiply this whole number to this fraction? Very simply, for an example, this is as a side note. If I say, what is 3 times 4 over 3? Well, what you do is, you put this over 1. What's 3 times 4? It's 12. 1 times 3 is 3. 12 divided by 3 is 4. Notice you just get the numerator. Here, when the denominators are the same, you could just cancel and just say it's 4. Okay? Now here, what happens here, just do this rule. Just cancel. So now I have absolute value 11 minus 4. Does this equal 7? 11 minus 4 is 7. So does absolute value of 7 equal 7? 7 equals 7. Yes. Same thing here. Cancel. So then you have absolute value negative 3 minus 4 equals 7. Then negative 3 minus 4 is negative 7. And it works. Okie dokie. Let's move on. Alright. Now, let's see. Example 4. Now these will get a little more tricky. So you see here it says 5 minus 4 times x plus 5 equals negative 39. So here, notice that the absolute value is solo. Here, the absolute value is not solo. So that's what we always want to do. Get absolute value solo, right? And I want you to treat this like a parenthesis. Let's say, for example, I said, what is 5 minus 4 times x plus 5 equals negative 39? All of you automatically are thinking, oh, let me distribute the negative 4, and you could do that. But let's say we didn't distribute the negative 4. Can't I just do minus 5, and then this cancels. Now I have minus 4 times x plus 5 equals, let's see, negative 44, right? And then what can I do? I could just divide negative 4, and this cancels. Now I have x plus 5 equals 11 minus 5, x equals 6. And you would have gotten the same thing if you distributed. Well, here, when you solve this, try and think of the same thing here. Get this absolute value solo, and it was the same way as if it were parentheses, right? So minus 5. What do I get? Negative 4 times x plus 5 equals negative 44. Now let me show you rookie mistake. You cannot say negative 4 times x plus 5 is the same as absolute value negative 4x minus 20. Let's just put a big red. Cannot distribute into the absolute value. Okay? You cannot do this. Okay? You cannot do this. So what do we want to do? We want to get the absolute value by itself. So you divide negative 4, and now this cancels, and now we have absolute value x plus 5 equals 11. And you say, Mr. G, what was the whole point of doing this? And it comes back to our formula, right? They're saying that when this absolute value is solo, when it's by itself, you can do this move. Here, our absolute value, our equation, it wasn't solo. So we couldn't do this move yet because it wasn't solo. But now look, we got it to be solo, so what can we say now? We can say that from here, the formula says, if this is positive, then we can say x plus 5 equals 11, or we can say it's the negative version, or x plus 5 equals negative 11. And here, what does x equal? X equals 6, or x equals negative 16. And what I want you to do is check it. Check to see that this, when you plug in 6 into the original, it works, and when you plug in negative 16 into the original, it works. Okay? Let's see. For this question here, the absolute values are solo. Basically, what you can say is 2x minus 1 is equal to 4x plus 9, or 2x minus 1 is equal to the negative version of 4x plus 9. And then now, you distribute the negative into here, solve for x. Alright, and there is a loud sound outside. Hold on 1 second. Here. Last question. Absolute value of x equals negative 5. Well, remember, our theorem says this value, right? This a value on the right side has to be what? Greater than or equal to 0. Here, negative 5, I mean, that's weird. Think about it. Imagine what the absolute value of some number is negative? Is negative? Question mark? Negative? It's not possible. Remember, definition, our absolute value, hold on. Remember, distance, this is distance, right? They're saying that some distance is negative 5. This is no solution, right? It's not possible, right? If you want x to be 5, that won't work. Absolute value 5 does not equal negative 5, and also with the negative 5, it won't equal 5 either, right? I'm sorry, yeah, negative 5 here, because this is 5 equals negative 5, 5 equals negative 5. It's not possible. So here, this is no solution. All right, guys, have fun with these, all right? Have a lot of fun. Do all of them. Okay, I'll see you.